Hi everyone, my name is Muhammad Khalid Ramadan today, and I'm from Group 13, and I will be presenting about mobile iOS architecture and OS concept. We move to introduction to mobile iOS. iOS is Apple's proprietary mobile operating system built upon a secure, highly integrated software hardware stack derived from macOS. Its core engine relies on unique like an unique subsystem named Darwin. Modern Genesis, unveiled in 2007, pioneering intuitive multitask gesture. Microkernel Foundation harnesses Apple's custom engineered silicon integrated with Darwin primitive. Operational focus, specially optimized for high operational fluidity, robust device level security, and minimal power drain. And I will pass to my friend next.
My name is Adam Skandar bin Abdullah. Now I'm gonna talk about 4-layer OS structure. First, we have Cocoa Touch. The topmost UI layer defines the visual front-end interface, handles multi-touch inputs, gesture recognizers, and application lifecycles using frameworks like UIKit and SwiftUI. Second, Media layer provides multimedia features, graphics, engine support, and hardware acceleration via advanced low overhead APIs including Metal, Core Graphics, and Core Audio. Last is Core Service, manage foundational feature behind standard system functions. Features core safe database, localization service, cloud storage or cloud kit, and fundamental input-output libraries.
Okay, this slide explains the role of Cocoa Touch and media layers in the iOS operating system. On the left, we have the Cocoa Touch UI frameworks, which are responsible for managing the user interface and user interaction. It provides standard APIs such as SwiftUI and UIKit, handles touch events and gesture recognition, and manage the application lifecycle, including active, background, and suspended state. On the right, we have media and graphic acceleration, which enhance the performance of graphic and multimedia processing. Metal provides fast and efficient GPU-based graphic rendering, while AV Foundation and Core Audio support video capture and low latency audio processing. Core Animation enables smooth and hardware accelerate user interface animation. In summary, these layers work together to create responsive, visually appealing, and high-performance iOS application, delivering a better user experience.
My name is Muhammad bin Ardin. Next, I will continue about core service and XNU kernel layers. For core service, standard middle tier database. Manage background task, location tracking via core location, structure data via core data, and deep platform synchronization via CloudKit. Match microkernel, low-level thread and memory allocation. Preemptive priority scheduling, virtual memory pegging, robust message passing, and thread primitive directly connect with silicon cores. BSD subsystem, POSIX layer compliance. Implement top-level Unix model, process IDS, PIDS, advanced networking socket, file system wrappers, and secure POSIX system calls. The XNU hybrid architecture. iOS contains the XNU X is not Unix kernel and advanced hybrid kernel architecture inside Darwin OS. By binding the QUI inter-process, communication of match and matcher, robust POSIX abstraction of BSD, iOS gets superior application protection without incurring the high overhead of classic academic microkernel. My name is Muhammad Afif bin Ardin, so I will continue this presentation. To avoid the high computing resource, cost of developers spawning raw, unmanaged threads manually, iOS abstract concurrency with Grand Central Dispatch. First, system thread pool. GCD manage a dynamic pool of worker threads, adjusting allocation based on physical CPU stress. Secondly, FIFO QU structure. QUs can run synchronously or concurrently, disrupting multiple jobs at once. Third, dynamic power adaptation links QU priority flags directly to match kernel thread scheduler, shifting core configuration dynamically. My name is Muhammad Ahminuddin, so I will continue for thread-based scheduling and QoS. iOS focus scheduling entirely on individual execution threads instead of whole parent processes. High priority tasks target performance cores, P cores, while background activities rely on efficiency cores, E cores. QoS class for user interactive, priority level, highest 47 to 63. Description and resource allocation, activate animation layout rendering and input processing, immediate UI response. Hardware root, P cores, max time. Secondly, for QoS class for user initiated, priority level high 33 to 46, description and resource allocation, loading file, opening local document, user expect rapid result before continuation. Hardcore root, P cores immediate. QoS class for utility, priority level medium, 17 to 33. Description and resource allocation, file download, persistent network syncs with active progressions. Hardware root balance core mix. QoS class for background, level priority lowest 1 to 60. Description and resource allocation, metadata indexing, local background backup, completely invisible to the user. Hardware root, eco energy safe.
Okay, now I'm gonna talk about deadlock handling mechanism. First, we have kernel ostrich algorithm. At the kernel level, iOS keeps active runtime deadlock cycle detection algorithm to prioritize processing overhead and battery consumption. Mean of spin control watchdog is if a deadlock hits the primary UI thread rendering thread, a system timer forcefully crashes the app, releasing locks instantly. Second, we have GCD-driven prevention. Instead of heavy, error-prone software logs, developers protect critical share structure using an architectural pattern include FIFO series queues. It runs only one operation at a time, enforcing isolation safely without log nesting. Then, automatic priority boosting is prevents priority inversion by upgrading dependency thread privilege.
Okay, I'm gonna talk about APFS or Apple File System. First, we got instant cloning. Instant cloning enables files or directory to copy instantly without duplicating disk space. APFS maps both entries to the same block, writing new block only during active edits or copy on writes. Next, we got snapshot. Snapshot creates immediate read-only instance of the operating system state. This makes critical software updates and recovery procedures clean, safe, and stable. And last one, we got space sharing. Space sharing allows distinct storage volume inside a container to dynamically claim the physical disk space from a unified free storage pool instead of enforcing static size boundaries.
Moving on next, we have application sandboxing and security. The isolated sandboxing model, iOS lockdown permission by encapsulating every application in its own strict security container. Apps are barred from accessing core OS asset or peer directory file. And these are the native hardware encryption. We have block level AES 256, verified on storage features, and individual on disk protection keys. Next is secure enclave coprocessor. Cryptographic card keys bind to both the physical device's unique identifier and user's secret passcode. And lastly, safe recovery. If storage chips are physically removed, raw files remain totally unreadable without specific user credential. And that's all from our group. Thank you.